Here's a tutorial for the vectors 2. Here's a tutorial for vectors with Edpuzzle 2. So I assume you can see the paper and read the problems. So I'm going to go through the explanations of the math here. So our little car went 60 centimeters west and then 30 centimeters at 40 degrees north of west, and then 70 centimeters due north. So we get this with an arrow, this with an arrow, this with an arrow, and you need the arrow so that we have the direction, because the car has to travel from here to there and not through here because we're looking for the total final displacement, which is from here to there, because the distance overall is from here, straight line, to there. And this is the direction, not this one. And we're not going to take the displacement as through here. The displacement is a straight line from start to finish. That's what we're doing with a direction in it. So our displacement will be from here, arrow, there. Okay. And the Mr. P on the video called it resultant vector, I think it was. So I put R for the hypotenuse here. And I know that's not a triangle yet, but we'll make it one. So it will be a hypotenuse. So if I complete these lines here, what I make is a right triangle. However, I don't know the value of this distance and that distance, but I can find it because I know that this angle was 40 degrees off of the horizontal, and I know that this length is 30 centimeters. So let's take this triangle and blow it up here. And now I have 40 degrees, and I'll call this X and that Y. And I know that the hypotenuse is 30 centimeters. So sine of 40 degrees will be opposite over hypotenuse. That's why over this, put in sine 40 degrees on your calculator, you get this. Now remember, this has to solve for y, so this moves diagonally over here, and so this times this gives me that. Cosine of 40 degrees will be adjacent over hypotenuse, so we get x over 30 centimeters, and this moves diagonally, we get this times that, we get 23 centimeters. So now I know this distance and that distance. So what's the total distance west? Well, it's the 60 centimeters plus whatever I just found for x. So it's 60 centimeters plus the 23 centimeters, and that's a total of 83 centimeters west. The total vertical will be the 70 centimeters plus whatever I found for y. So it's 70 centimeters plus the 19.3 centimeters that I found for y. And so the total north is 89.3 centimeters. For 4, it says, show how to find the interior angles. So I want this angle and this angle here. Well, now I know two sides of a triangle. I know that the total west side or bottom and the total north side or left side. And what relates those two sides is tangent. So tangent, and Mr. P called it phi on the video, so I called it phi, which is the vertical line in the circle. That's a Greek letter. This angle he called phi. Well, I know his diagram was reversed. I purposely reversed this, but his main angle that he was dealing with, he called phi because he called this one theta, which is the horizontal line in a circle. So tangent of the angle anyway will be opposite over adjacent. So that's the north value over the west value. North over west will be equal to tangent of whatever the angle is. So let's divide this. We get 1.08, and that is the ratio of the sides. Now, if we use inverse tangent, we can make the calculator return the value of the angle. So your calculator may say inverse or second or shift or something. Look above your tangent button, and it probably says tangent to the -1 power or something like that. So I would play with your calculator until you can make it use the inverse tangent function of 1.08 be 47.1 degrees or something really close. I think I didn't round this off in the calculator when I did it, so you may get 47.2 degrees or something. Let's not argue about that. So that is this angle here. What about this one? Well, in a right triangle, this angle and this angle that aren't the 90 degrees must add to 90 degrees. So the total of this angle must be 90 degrees minus that one. So 90 degrees minus the one I know is the other one. So here's my 47.1 degrees that I found here, and 90 minus that one gives me that one. 5 says, show 5 ways to find the total displacement vector. So that's R, and really we should have arrows there, shouldn't we? Anyway, effectively that's what it did. So now I know both sides and I know both angles. So there's quite a number of ways, at least 5, that I could find this. I could take sine of 47.1, which is opposite over R. Opposite over R. Now, take this value in your calculator, but remember that it trades spots with R. Everything moves diagonally, so this trades spots with that. These switch places when we solve for R, and we get 89.3 over the value we got for this. This moves down here, so we get this, and then we divide, and R value is 121.9 centimeters. Cosine of that would be this one over R. And again, these trade places, find that value, put it down here and divide. You'll notice we get something close enough that it's probably good enough for now. Sine of this angle will be opposite over R. And notice we get exactly the same thing as cosine of the other one. These are the same thing, literally the same thing. Not only do you get the same answer, it's the same setup. Cosine of one angle equals sine of the other angle. And so then cosine of this one is going to be equal to sine of that one. And so D on my answers here is the same setup as A. Yeah, as A. And then for E, sorry, it got smeared here, could be the Pythagorean theorem. For 6, we have a different problem. The little car goes 50 centimeters north, 65 centimeters east, and then 30 centimeters at 35 degrees north of west. So we draw this out, find the component vectors of C. So let's take this little triangle. Let's make a little triangle out of this. And let's take this one and put it down here just so we can look at it. So we know the hypotenuse, don't we? And we know the angle. So I can find the vertical part of this and the horizontal part of this. I'd call them X and Y. So sine of 35 would be opposite over hypotenuse. So we get sine of 35 degrees and multiply by 35 centimeters and we get the Y value. So this is Y here. And cosine of this would be X adjacent side over hypotenuse. So we get X over 30 centimeters, cosine of 35 degrees in your calculator equals times 30 centimeters, and we get 24.58 centimeters. So X is 24.58 centimeters. Now here's the thing. X lies on top of B. So what's the length of this portion of B then? Well, it's 65 centimeters minus whatever we just found here. And my point is that the little car doesn't end up using, in the very end, all of B. It only uses this portion, right? Because it ends up only this far east. So how far east does it end up? Well, it's 65 centimeters minus this bit. So here we go, 65 centimeters minus the part of X that the part of B that is X that we found. And so it really, in the end, only used 40.4 centimeters to the east. 9 says to relabel everything. So let's do that. 50 centimeters north and effectively only 40.4 centimeters east because this part got essentially removed by moving back this way. This is still 30 centimeters and this is 17.2 centimeters. And I call these CY. I call this CY and I call this B1 and B2 here. Now here's the tricky bit. Let's make a right triangle out of that. And it may seem that that is impossible. Let's take this piece and move it over here. And then this piece and move it down. Then I have, oh, and then this piece sits on top of this piece. So here's my total vertical, 50 plus 17.2. Let's put them together and then move this down. And that's my bottom of my right triangle now, the 40.4 centimeters. And here's what we get. And so my total displacement is r, again, resultant vector. And I just call them theta 1 and theta 2 here. So 11 says to find all the sides and interior angles. Extra credit challenge, don't use the Pythagorean theorem, and use both sine and cosine and both angles. So find it twice. So how do I do this when I don't know any of the angles? Well, it is possible because I know I have a right triangle and I have two sides. I have the vertical and the horizontal, and we could use tangent to find that. Now we could use tangent to find either one of these. I just did theta 1. You could use theta 2. It doesn't really matter. But tangent of this will be opposite over adjacent. And remember that the total for the vertical is this, right? So tangent of theta 1 will be the total vertical over the horizontal. So divide, and you get 1.66. I think it repeats. And what we're going to do is do inverse tangent. So I would suggest actually using your calculator, making sure you can use inverse tangent of 1.66 and get something really close, at least, to 59 degrees. So theta 1 is 59 degrees. Well, theta 2 must be 90 degrees minus 59 degrees. So it's 31 degrees. So what's r? Well, the extra credit challenge was to use both angles and sine and cosine. So let's take sine of one of them. It doesn't matter which one. I did sine of theta 1. And that's total opposite over hypotenuse. And again, remember, these are going to trade spots. So take this value and put it under, and then r comes over here. And then we can divide, and we get 78.4 centimeters. Cosine of this one is literally the same thing it ends up being, right? Because opposite over hypotenuse, and we get literally the same setup. And of course, these trade spots again, and we get the same answer, of course, because it was the same setup. So what's the final displacement? It's the value of r, but remember, displacement and vectors include a direction, not just a distance. And a lot of math classes don't really emphasize that, so I'm making a bigger deal of it here. So it's 78.4 centimeters, and the direction is 59 degrees north of east. Remember, this was 59 degrees north of east from the origin.